I'm going to talk today about tooling for Scala 3 and essentially how it all relates to metals and what kind of other tools there are that we use in metals that also enrich the whole Scala ecosystem. So as I said, please ask questions in the chat. I'll try to answer them at the end if we have time, or at the panel after all the talks. So we will get to all the questions you have. Let's start with the explanation. Why am I here? So I'm working at BuildServer, as Christoph said, and we've been involved with the Scala community for around 10 years. We always wanted to give back to the community to make sure that we add value to the Scala language. And there's a particular other organization that also keeps those values close at heart, which is the Scala Center. And since last year, we are actively collaborating with Scala Center as a contributor member, which means we provide one contributor to Scala Center to work on metals. So I'm currently working on metals as one of the main contributors, and this is the part of that collaboration. But metals wouldn't be what it is without the contributors. So obviously, the main person here is Olaf, who started the whole project, did the main work on it. Another important person is Jorge, who did a lot of work and is the co-author of Bloop, without which metals wouldn't exist. We also have Miriam, who is another developer from Scala Center, working currently on metals and also working on metals and ScalaFX integration. It's also important to mention Chris, who is taking care of a lot of the work on the Vim metals plugin, which is pretty cool. So if you're into Vim, please do check out the COC metals. But it's not just those 4 people. There's a lot of people who contributed, and I'd like to thank everybody. Tooling is a very difficult subject, so it's amazing that we had so many contributors from different parts of the world, and even one cat. So as you can see, also Scala Stewart is one of the main contributors, which is a fun fact. Okay, let's start talking about metals. So metals is a Scala language server with rich IDE features. Let's concentrate on the first part. Scala language server. The language server protocol is a protocol, JSON RPC protocol. So JSONs are sent between a server and client to communicate. And it was done by Microsoft in order to make integrating different languages and different editors easier. So normally it's the case of n+n integrations, n times n integrations. So we have n editors and m languages, and we need to integrate each of those with another. But thanks to the protocol, it's n+m. So we just need to implement the language server protocol support in each editor and each server. And currently in Metals, we support 6 editors, that is Visual Studio Code, Emacs, Vim or NeoVim, Sublime, Eclipse, and Atom. So you've got your favorite language and your favorite editor. So favorite language, obviously currently Scala. Just quickly on how it works. So let's say we have some code and we've typed some characters. and we'd like to know what completions we can get. So what can start with those characters. So we create a request, send it to an LSP server, and then the LSP server is thinking for a bit, and then sends in a request. As suspected, there are two members here of that response. The response is then later presented to the user. User can choose what they want to apply, and that's applied. So this is basically how it works. And what I showed was just the completions, but there's a bunch of different features available via LSP, which, for example, diagnostic, go to definitions, hover. A lot of that is explained better in the LSP specification, and they're pretty amazing. That's a pretty good specification that you can find all the information you want. But we've got even more possibilities with extensions. So you can actually extend the LSP, the language server protocol, with custom requests and responses, which, for example, in methods enables worksheets or the tree view and some other things that you most likely use if you use methods. So not everything comes from LSP. Some of the stuff we implemented as extensions, but it was pretty easy to implement those extensions. The only drawback is that it also needs to be implemented. The extension needs to be implemented in the editor. So we try to keep as much as possible to the core LSP method. Okay, so that was the language server protocol, which is obviously the most important part of what Metals is. But we also have the BuildServer protocol, which is a very similar protocol, which this protocol was created at the Scala Center that solves the issue of connecting with the build tool. So language server protocol knows things about the language, but it doesn't know much about the build tool. And there's a lot of build tools. There's a whole universe of build tools that can support Scala. So we've got 6 that we support. There are more build tools that support Scala, and Metals is in between that. And if we tried to implement every build tool support, it will take a long time, and we wouldn't be able to do it. But here comes Bloop. So Bloop is actually able to create, there's some different plugins, like for Maven and for some build tools, it's part of the core functionality to create JSON configuration files that tell Bloop all about the build. So what the dependencies are, what the build target, so in essence, projects are, what are the source files, everything like that. And Bloop can later start and then serve responses to the LSP server, which is Metal. So let's go quickly over how it works. So in difference to LSP, this mostly BSP and Bloop works between the server and another server, which is the BSP server. So you can also use Bloop on the CLI, but it's not that important to Metals. So let's see. For example, an LSP server might have some source file, but it doesn't know what project it belongs to. So it just sends a request to Bloop. Bloop thinks about it and then sends back information that this actually belongs to the project full, the target full. Okay, but LSP server doesn't know how to compile it. So it just sends the request to Bloop to compile it. Bloop compiles it and maybe sends an error report. And that error report can later be sent via LSP to the editor, and the editor can present those diagnostics. So this is so we've got these 2 protocols. There's third one that I will be not explaining, which is DAP, debug adapter protocol, used for run and debug. But this is not one of the core, it's not the core protocol that is needed for methods. It is very useful in case of debugging, but BSP and LSP are the most important ones. Okay, so we've gone through what metals basically is. My talk is about Dotty though. So let's talk a bit about Dotty. So Dotty is the project name for all the technologies that are supposed to be included in Scala 3. And there's on the website, you can see that it's supposed to be more opinionated. There's an example of that on the left. So normally in Scala, you could add equals or not add it, but in Dotty, you'd always have to add equals in case of method definition, so more opinionated. It's also simplified in some regards, or at least that's the intention. So we'll probably show some examples later. It's supposed to eliminate any inconsistencies. So if you ever had any, really surprising moment in Scala and that boggles your mind, the intention is that it will never happen with Dotty. There will be some strong foundations, so the dot calculus, which I'm not, so I don't know much about it, but it's supposed to have much better theoretical foundation. And Dotty is supposed to improve a lot of the problems we have with Scala 2. Okay. Let's go maybe over some, maybe not everybody know what are those changes. So let's go over some of those changes. First of all, I start with the big guns, so the optional braces. Optional braces is one of the most discussed changes to Scala. And some people say that it really simplifies how the code looks, removes those unnecessary braces. But on the other hand, there's people saying that it's changing core structure inside of an already well-established language. So in essence, there's a lot of people against that change. You can still use braces in your code base, so that will most likely not change, but it is a very hot topic currently. Another nice feature that might be familiar to people, for example, from Kotlin, is explicit nodes. So you can turn on the -y explicit nodes flag, and whatever method can return a null, for example, coming from Java, it will have the type string or null. It's a different null when coming from Java, but I will not be delving into that. And you will have to handle it. So it's pretty good to avoid any null pointer exceptions, and it's very widely used in Kotlin. And there's a very similar thing in TypeScript, I believe. Another big change is outer methods, or top level methods, I should say. So you can define methods without any class, without any object. Those can be the main methods. So you can just annotate it with the main. And if you annotate it with a main, there will be a parser created that will try to parse the arguments. There's the basic types, I think, are implemented. You probably need to implement some parsing for any more for anything more difficult. So any custom types and things like that. And so this is actually simplifying the language a lot. You don't have to explain to people, hey, you need to first create this class. It needs to be an object. You don't have to explain all that. You can just create a method annotated main, and that the hello world is much simpler. Another thing that simplifies things, at least that's what I think, is extension methods. So extension methods will basically be the same thing as implicit classes. Not 100% the same, but it will serve the same purpose. And it's nicer syntax for defining additional methods on already existing types. So for example, here you can define on circle a new method that calculates circumference and returns a double, and it can be defined outside of that type, it looks pretty nice and reads pretty well as well. Last but not least is a thing that a lot of people missed in Scala, which is enums. So enums are coming to Scala, and some people might be happy. I think it is very useful. There have been numerous occasions where I needed enums and there was none, and I had to just go around it in some way. So yeah, those were the language highlights, but those language highlights are also tooling pain points. We get all that new syntax with optional braces, which the current tooling doesn't know anything how to deal with. There's new soft keywords. So soft keyword is a keyword that if it's in a certain place, for example, inline, if it's before a parameter, it is a keyword. But if it's an identifier, you can still have an identifier that's called inline, and that if it's in another location, then it's not a keyword. So that soft keywords. The top level methods are another thing that totally changes the way the tooling needs to work. There's some complete new structures like enums that we need to start working on. So those language highlights are some pain points for the tooling authors. Okay, but it's not all bad. We already have some support of Scala 3 in metals. But let's start off what is available in metals by talking about semantic DB. So in semantic DB is those protobuf files, so files, bytecode files, it's not the byte files, could say, that are easy to read and write and are pretty efficient in that regard. And those files are created in Scala 2 by the compiler plugin, and they're used for navigation and indexes. That looks basically like that. It's when you read that file, it gets some details. It says what symbols are defined in a source file. So there's semantic DB file per source file, and it says what symbols occur in that semantic DB file. Symbols are just anything like uniquely identifiable, for example, method or value or a class. So each of that is uniquely identified within one workspace. Okay, and semantic DB can now be generated in Dotty with the new, it's not long so new, but the Y semantic DB flag help generate those semantic DB files that are needed for metals. And this is also added automatically by Bloop whenever metals connects to it. So you don't have to worry about it. And this great work was done, started by Martin Oderski during the last SphereIT conference, and continued and finished by Jamie Thompson from Scala Center, who did a lot of the great work that made it all work. So that's semantic DB. So that is working. Another thing that contributed to metals is actually the Dotty LSP server. So Dotty LSP server was already a thing. It was already functioning. It was working the same as metals via LSP. It enabled type checking, some compiler errors, type information hover, go to definition, finding references. So we actually reused that in Metal. So we reused the code of .lsp server in Metals. And this way, we reuse it in a way that works together with existing features. You can have modules with Scala 2 and Scala 3 in the same project. It's done by doing this separate module that is compiled with Dotty that we can communicate with from the Metals main server via Java interfaces, so that we can communicate with any Scala version and there will be no binary incompatibility issues. And that is released for each Dotty version that we support. So yeah, we reuse the LSP server, and most of the things that work in the Dotty LSP server work in Metals. To sum up what is currently working, that is diagnostics, go to definition, all the things on the left. There might be still some things to fix, to work out, but those things on the left are working, possibly with some bugs. Things on the right are things that we still need to work on. So formatting will not happen for a while. Folding also not available. So we will work on those things, but there are some problems that we need to first figure out, some challenges, which I will be talking about next. All right, so there's a short demo. So currently there's several ways that you can get started with Dotty. First one is actually by using Cursor. So you can do Cursor install BuildServer 8, which will install template engine G8. Now we can do CS G8 and use the template for Dotty. We can use default name. Then we can go into Dotty project template.
Cool. Tomasz, could you just increase the font a little bit?
Yeah, that would be good. Yes, sorry about that.
Thank you so much.
Zoom in. All right, is it better?
Yes.
Let's do one more. Okay. So basically now we have a workspace working with Dotty, and now we can do code. And that will open up a workspace that you can import. Let me see if I can make it bigger too. Zoom in. Equals. No. Okay, so we are importing the build. Okay, that should be a bit better. And so this importing creates the bloop files that we need for the workspace. And now we're loading the presentation compiler, which might sometimes take a bit of time. Hopefully not too long. Okay. Yeah. And the workspace is compiled. We can actually run and debug that. All right, so that's one way to do it. Another way that was recently merged was that it's not yet available inside Metals is using this shiny new button called the new Scala project. So here we have a totally empty workspace. If we have an empty workspace, we display this welcome view. So whenever you click it, it activates the Metals server. And once the Metals server is activated, it will create this, it will start the new project creator. You can actually write a custom template, or you can actually download the template available on the Guitar 8 website. So this is a lot of different templates that you can use, or you can go back to curated ones and just use the Dotty one. You can go to the workspace, name Dotty. That will start the creating the template, and you can open it in a new window, and basically the same thing will happen here. So there will be two ways, one for everybody who likes to use command line, and the other one for people wanting to use an IDE. Okay. So you can, so that is the second way that via the new project wizard, which is coming soon. The release, I plan to do the release this week, although there's one thing that I need to do still. So that might not be this week, but maybe we'll do it right after the new Dotty version, so that the new Dotty version is properly supported. But that's not the only way to test out Dotty. So you can actually go to my fork of the Dotty example project, and if you click on the first link available, it will start a Gitpod workspace. Gitpod is an online IDE that can reuse any VS Code extensions, so Visual Studio Code extensions, such as Metals, and provide the same experience as you would get from Visual Studio Code. You can use the link here, but it might be easier to go to the to my fork of the Dotty example project, or I will actually do that myself. So this starts this pulls the Docker workspace. That workspace was actually pre-built by me, so it will not require a lot of loading, and hopefully it goes fast. It still takes a minute or so to start the workspace, because it's basically Docker. But yeah, so we've got the workspace. It's downloading Metals. Might be not need to import the SBT, because SBT is actually imported beforehand, and you can actually run the example. So this is the Dotty example that is set up by the Dotty team. So you can run it. You can use all the features of an IDE with Dotty here. So works pretty neat. If you test it out, it's still using 0.90 version. There has been a lot of improvements since then that will be available in the next release, or that you can actually change the version. If you go to preferences, you can actually change the Metals server version if you which doesn't seem to, oh yeah. So you can change the server version to the newest one, re-download the version. You might need to re-import, not sure, but it will benefit of some improvements, especially we've got some improvements when it comes to breakpoints. Okay, so that was the demo. So that's what is currently possible with Metals. But let's talk about more general tooling ecosystem. So Scala is not just the compiler. It's the whole ecosystem of tooling that enables you to have a good experience with the language. And in order to migrate any workspaces, we need to provide the same experience as they would have with Scala 2. So that means that we need to first work on a thing known as the Scala meta parser. It's just a parser that works independently from the Scala compiler, and it's the basis of a lot of developers' tools, which I will go through now. It is quite fast. It creates this understandable abstract syntax tree, and it needs to be needs to support the new Dotty syntax. So, for example, one of the things that uses the Scala meta parser is Scala format. So Scala format is the thing that automatically, for any of you that don't know, is the thing that automatically formats your code according to some rules that you specify or according to the default one. And it is important for a lot of teams so that the Scala format is done, for example, on CI, and make sure that the formatting is consistent across the project. And for some teams, it might be considered a blocker to the Scala-free migration. Another tool that is widely used inside the Scala community is ScalaFix, also based on the Scala meta parser. So it will not currently work with Scala-free. It allows you to either refactor some code. So, for example, it might remove some unused imports, or it can be used for linting, which means that it will just show you some code smells that are located within your code base. Okay, so this is also might be used on CI and might be important for a lot of people that it's used to automatically reduce a lot of the code smells that are present in the workspace. Another tool that is based on Scala meta parser and is actually used maybe not that widely. I'm not exactly sure how widely it is used, but for sure it's used for the metals worksheet is mdoc. mdoc is used to evaluate samples of code inside of Markdown file. It connects all the samples inside one Markdown file into one source file, and it compiles it and produces the information about types and the values inside of the code. So as you can see on the right, we reuse that same logic for worksheets. And also inside metals, the parser is used for a lot of things like folding ranges, document symbols. Some of that can be also done using the Dotty parser, but that will require a lot of additional work, which we wouldn't have to do if the parser supported that new syntax. Okay, so because of that, because of the problems that we will be facing within the Scala-free migration, we created a roadmap that you can take a look at, and it explains what we plan to do in the coming months in order to make the Scala-free migration easier. The roadmap consists of 4 milestones. First milestone, there's some smaller issues that we'll be fixing first. So the basic support for completions inside metals and for Dotty is all the same as the one for the Dotty LSP server. So it's not on the same level as the metals one. So we'll be starting with some smaller fixes in the first milestone. We'll also be working on making sure that the Scala meta parser supports all the new syntax but the optional braces. So the optional braces, we're not yet sure how much time it will take. So that will be coming in the second milestone. We'll also take care of some more advanced issues that we still need to do for Scala 3, alongside with the optional braces support. In milestone 3, we'll work on option for a standalone compilers for files that are outside of any target. We'll work on the Scala format for Scala 3, which should unblock a lot of teams migrating. We'll add all the advanced completions such as exhaustive matches or things like all the addition. If you're using methods, anything that is not just the scope completion, so it's just not what belongs to object or a thing that is available inside of scope. Everything that is not that is an advanced completion in that sense. So that will be milestone 3, and furthest milestone 4 will be making sure Scalafix works and that we have a proper worksheet working based on the mdoc, which will be working for Scala 3. So those are very rough estimates. They're not to be taken that they're more calculating the complexity of each of the items, but it does show the amount of work that is needed for the tooling ecosystem. It puts focus on the tooling, and it makes all those goals about migrating to Scala 3 more realistic. If people know what's going on, it will help them to adopt the mindset that, yeah, it's possible to migrate to Scala 3. So do comment if you have any opinions about any other tools that should be migrated. We will most likely first work on the things that are included in the roadmap, but if there's anything that you think is lacking, we'll also discuss it there and see what we can do about it. Right. So that's tooling ecosystem. Recently, we've been working on still more features for Scala 3. So the support for Scala 3 was merged recently, but we are also working on some other features such as go to parent code lenses, which is disabled by default. Sorry, Krzysztof, did you?
You know, the time is almost running out, and we got one question for you.
All right, so I'll just quickly go. So those are the new methods features that we've been working on. Coming soon, there'll be Ammonite script support. The new project provider that I showed will be. We recently merged also better breakpoint support for Dotty and a lot of different Scala 3 improvements. If you want to look at any future work that might be coming to Metals, you can take a look at the issue tracker or the Metals feature request issue tracker, which contains all of the ideas that people have or we had to improve Metals further. If you have any questions, I'll try to answer them in the chat or the panel. I think we don't have much time, so probably at the panel. There's documentation for each of the things I was talking about, and you can always chat to me on GitHub or Discord or at Twitter. I recommend the last year's Scala Days talk by Olafur, which is a great talk and talks a great deal about the user experience of Metals. Okay, so that's it. Thank you for Virtus Lab for organizing this, and yeah, that's it.